Okay, today's lesson is going to cover how to solve quadratic equations. And quadratic equations is a fancy word for just an x squared equation. Linear equations are the ones we've been solving that the highest term is x. Now we're going to start solving things that have a squared value in them. So typically we talk about quadratic equations in the form ax squared plus bx plus c equals 0. Now, this is really important to notice that we are going to have a coefficient a with our x squared term, coefficient b with our x term, and some constant term. And very often we're going to want to manipulate our equations into this form before we start. So there are really 5 things and ways to solve. We can solve quadratic equations by factoring and applying the zero product property. We can solve them by using the square root property. We can solve them by the quadratic formula. We can solve them by completing the square, and we can solve them by graphing. Now we've done a little completing the square. We're not going to cover these two. We're only going to cover these two today. So factoring in the zero product property. So just for review, quick, if I have 8 times 0, the answer is 0. If I have a times 0, the answer is 0 because any number times 0 is 0. So if I have 7 times some number and the answer is 0, that number in there has to be 0. That is the basis for the zero product property. It says if a times b equals 0, then either a is 0 or b is 0. One or the other of them must be 0. It's the only way to get 0 under multiplication. This is what we use to solve quadratic equations. So, steps. Number 1, make sure the equation is in the form ax squared plus bx plus c equals 0. If it's not equal to 0, use your algebra skills to add and subtract away so that it is. And then make sure it's in descending order of your exponent. So I have my x squared, then my x, then my constant. Go ahead and factor it into 2 quantities. And we've been practicing that. I've now taken what was an addition problem and I've turned it into 2 numbers, even though they're quantities, 2 numbers multiplied, and we set them equal to 0. Now it looks just like a number a and a number b. And we can set each of those quantities equal to 0, solve each little mini baby problem, and you get the answers. And that's why those factoring lessons were so important. So let's look at some examples. So x squared minus 5x plus 6, parenthesis, parenthesis, x on each side, minus plus is minus minus. What factors of 6, when added, make 5? We know that those are 2 and 3, and this is still equal to 0. Now by the zero product property, if that whole thing will equal 0, either this equals 0 or this one equals 0. And so that lets us write x minus 2 equals 0. That's my first mini problem. Or x minus 3 equals 0. Both very simple to solve. X equals 2 or x equals 3. And if you put those 2 values back into the original, they will both make your problem equal 0. That's factoring. That's how simple it is. Let's look at example number 2. P squared plus p minus 52 equals 4. Well, it's not equal to 0, so I need to make it. So I'm going to subtract 4 from both sides. So I have p squared plus p minus 56 equals 0. That's my first step. Now I have something that's factorable. So I have parenthesis, 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 so equals 0. I have plus minus, so I have one of each. And which factors of 56? It's 56, 2 and 28, 3 doesn't go in, 4 goes in 14 times, 5 doesn't go in, 6, 7, and 8. Which of them, when subtracted, give me positive 1. And remember, we're subtracting because of the opposite signs. Easily, we see that I need a positive 8 and a negative 7 to make positive 1. Apply the zero product property, p plus 8 equals 0, or p minus 7 equals 0. Because again, if the first quantity equals 0, it doesn't matter what's in the second quantity because 0 times anything is 0. If the second quantity is 0, it doesn't matter what's over here because 0 times anything is 0. Subtract 8 from both sides. P equals 8 is one of my values. Add 7 to both sides. P equals 7 is my other value. Now, of course, this can't always be that simple. So let's look at some more complicated examples. Again, this is not equal to 0, so I'm going to subtract 24k from both sides, and I'm going to drop that into the middle because I want it in that standard form. So I want to say 12k squared minus 24k minus 15 equals 0. Be careful to keep that negative on the 15. Check for common factors. I see a common factor of 3. So I'm going to take out a common factor of 3. So I have 3 times 4k squared minus 8k minus 5 equals 0. That leaves me easier numbers to solve. So I have 3. So now I need to, k minus minus means I have one sign of each. I need to look at my factors of 4, 1 times 4, 2 times 2, and my factors of 5, 1 times 5, figure out how they will combine so that when I subtract them, I get negative 8. So we are back to our factoring. And so I will start with my outside plus inside list, and if I take 1 times 1 minus 4 times 5, that's going to be 19. Positive or negative won't work. If I take 1 times 5 minus 4 times 1, that's going to be positive or negative 1. Doesn't work. So I exhausted that one. If I take 1 times 2 minus 2 times 5, that works. That gives me 8. So those are the pair I'm going to use. So I'm going to go over here. 4, if I put a 2 here, that 2 needs to be multiplied by a 1. And if I put a 2 here, that 2 needs to be multiplied by a 5. Now do a quick check. 10k. I wrote that wrong. Should have been one of each, like I said. 10k and minus 2k. That gives me positive 8k, which is the wrong sign. So then I need to go in and make this one positive and this one negative to get negative 10k, positive 2k. Do a quick check. 2k times 2k is 4k. Minus 5 times positive 1 is minus 5. So now what I have is 3 times 2k minus 5 times 2k plus 1 equals 0. Now this is really 3 numbers multiplied together. We don't have to think about this 3 because it's a constant term. It doesn't change. So my 2 baby problems are 2k minus 5 equals 0 or 2k plus 1 equals 0. If we had factored out a variable with the 3, then it would also need to be set equal to 0. But since it's a constant, we can ignore it. Solve these. I've got 2k is equal to 5. K is equal to 5 halves. Answer 1. 2k equals negative 1. K is negative 1 half. What's happening here is because I have a squared power, I'm getting potentially 2 answers. If I have a linear, just an x term, I only get 1 answer. If I have an x cubed problem, I could get 3 different answers. So now let's look at this example. And this one is horribly messed up and has an important thing over on this side. I never want to factor things with a negative squared term. So I'm going to move everything to the left so that that negative 8x squared becomes positive. So I'm going to add 8x squared to both sides. And I'm going to add 3 to both sides. And that gives me 8x squared plus 13x plus 5 equals 0. Now I have my factoring equal to 0. I've got an x on each side plus plus. And I need to look at how my factors of 8, 1 and 8, 2 and 4, are going to combine with my factors of 5 to make positive 13. So I start making my list, outside plus inside. If I take 1 times 1 plus 8 times 5, that's not going to work. What if I take 1 times 5 plus 8 times 1? There's my 13. So if I put a 1 here, the partner with 1 is 5. If I put my 8 here for my x term, its partner is 1. Take a quick check. My outside is 5x, inside is 8x. That's 13x like I want. First two terms are x squared minus terms plus 5. So what's my clean version look like? X plus 1 times 8x plus 5 equals 0. X plus 1 equals 0, or 8x plus 5 equals 0. X equals negative 1, or 8x equals negative 5. X equals negative 5/8. Tune in to part 2 for the rest of the lesson.